Side 2. All right, so we're going to solve this system. So let's start with this equation. Let's put it into slope-intercept form. We'll start by moving over 3x. Okay. So what's that going to be? 6y equals negative 3x minus 12. Thank you. And then let's get rid of the 6. So we'll divide out a 6 everywhere, and we get y equals negative 1/2 x minus 2. So there's one equation. Let's do a second equation, or let's just solve the second one. This one's a little different, right? What do I need to do on this one? Just divide by 2. Let me do that. This one's a little simpler. You get y equals negative 1/2 x minus 2. What's our conclusion before we even graph this thing? They're the same line. How many solutions?
0.
Infinite solutions. Yeah. This is going to be one where you have infinite number of points touching. So there's infinitely many solutions. So we're going to put a point at negative 2, down 1, 2 across, and in theory, we have 2 separate equations. So 2 lines would be defined in the same space. So 2 lines occupying the same space touch in infinitely many locations. So we have infinitely many solutions. Now, would it be accurate to say everything's a solution? No, I can't really say everything is a solution. By everything, we would mean every point on this plane, right? Every point that's touching. Every point that's touching. So every point on the line is a solution. But that doesn't mean everything, right? Just means every point that's touching. And there's an infinite number of points touching. Okay. Let's talk about number 4. Take a look at number 4. The graph line below represents an equation in a system with no solution. Write an equation, write a possible second equation in the system. So the key here is no solution, with no solution. So graphically, what are we looking for the lines to be have the same slope and different y-intercept. So it would kind of be helpful if we knew the slope for this line. What's the slope for this line? Let's see if we can't figure that out. Negative 1/4. Okay, so the slope we want is negative 1/4 So here's what you want to do maybe. Pick a point on the y-axis, whichever one bugs you the most. I don't know, I guess I'm picking, what is that, -4? You could pick whichever one, doesn't have to be -4 for you. But I'm going to pick -4. And then I'm going to go down 1 over 4. 1, 2, 3, 4. And I'll graph that line. I'm looking for the two lines to be parallel. Fortunately, it looks like they are. And I'm going to write the equation for that line. So this is going to be y equals, in my case, -1/4 x. And then what am I going to put after that for my particular line? -4. Or -4. Say if you picked a different point, maybe one up there, or obviously your y-intercept number would be the one that goes there. Okay, so it says write a possible second equation. Boom, there it is. Okay. So write an equation that would work, that would give you a no solution, meaning parallel lines. Okay. Ready for number 5? Tish. I just thought about this. I've had all kinds of different names for, students with different names. I've never had a Tish. Never had a Tish in my classes. Okay, Tish believes that the linear equations shown do not have a solution because they do not intersect. Yet. Ooh, I love that. Yet. Do you agree? Is this an example of a no solution? No. Do you agree? Obviously, we're all going to say no. What's a good reason? Because. What's a good reason? They have opposite slopes. Wow. Not only are the slopes different, they're opposite. One's positive, one's negative. We could have just stopped at they have different slopes, but not only that, they have opposite. One's positive, one's negative. They have opposite slopes. They have opposite slopes, so eventually they cross. So they will. Whoa. Sorry about that. Just got an email and everyone heard it. Okay. So they will meet. Boom. Okay. Number 6. It says circle the names of the two students whose equations would have infinitely many solutions. Okay. For infinitely many solutions, what do we want? Same slope and y-intercept. So the two equations in slope-intercept form should be identical. So really, we want these equations in slope-intercept form to see which ones are. Let's just see if we can do a little quick mental math. So this one is going to be y equals. So I would bring that over. That would make it negative, but I would divide it by a negative. So this would be y equals, well, actually just 2x plus 1.
Wouldn't it be -y?
Well, you want to divide by a negative to get rid of that. I'm just kind of doing the math mentally, if I can. So this would give me y equals 2x plus 1, right? Now this one, I bring it over. It becomes -2x. then I would divide by 3. So this would be y equals negative, actually negative 2/3. Negative 2/3 x, and then plus 3 divided by 3 is 1. So this one would give me y equals negative 2/3 x plus 1. So this one, I bring it over. It becomes positive 4x. Then I would divide by negative 6. What's negative 4, 6? Miss Han likes to send emails about this time of day. What's negative 4 divided by, what's 4 divided by negative 6?
Negative 2.
Yeah, eventually it simplifies to negative 2/3 x. And what's negative 6 divided by negative 6? Okay. It's those two, right? Let's just do this last one just because negative 6x comes over. So 6x comes over, becomes negative 6x, and you divide by 6, so you get y equals negative x, and 6 divided by 9 is 2/3, or 3/2 actually. Well, that's definitely not it. Yeah, the ones that were just pointed out, I think Hamilton told us, it's these two, right?
Yeah.
Ravi and Courtney. Okay. Last one. Abby bought a combination of streamers and balloons for a birthday party. The number of balloons Y was 3 less than 2 times the number of streamers purchased X. If Abby bought a combination of balloons and streamers, the following systems can be represented by the situation. Solve the system by graphing. Find the number of each combination purchased. Okay. All right. So the first thing we should do probably is rewrite this equation in slope-intercept form. X plus y equals 9. All we got to do is move that x over. What do we get? Y equals negative x plus 9. So now we can graph this guy and that guy. So let's do that. Let's start with this one. So it's going to cross here, then we go down 1 over 1. Okay, I'm just going to make all the points there because we can't have negative balloons or streamers, right? So since we want everything to be positive, I'll just graph that. And then let's graph the second one. And so this is going to cross at negative 3. And we want to go up 2 and over 1. Up 2 over 1. Up 2. Okay. There we go. Yeah. My points were a little off, I think, but yeah, my point was a little off. I should have been right there. It's up 2/1. Okay. All right. All right. So let's write down a summary real quick. So let's summarize today's lesson. What are the most important things from, well, yesterday and today? So let me just get it started. You can solve a system by graphing and then what can we add on to that? You can solve a system by graphing. What are we looking for? What are we looking for when we're graphing, after we graph them? Looking for the intersection. If the lines are parallel, what's the conclusion there? There is no solution. And what's the last possibility? If the lines, shall we say, overlap? There are infinite solutions. All right. Okay. So that's going to do it for solving equations by graphing. We're going to have some IXLs on this assignment. Tomorrow we're going to start learning about solving systems by what's called the substitution method. I want you to, hopefully it's still working. I see a few people still looking and writing, so I'm going to leave this up. But go ahead and go on to IXL, and hopefully it's still going to ask you to join a group jam. I set it up at the beginning of lunch. I don't know if this thing times out.
After the group jam, I go to the restroom.
Okay.